right, the second part of question 3 was this problem. Hopefully you did this between watching the last video and starting this one. First thing we're asked is to find the domain. Now, this root is a square root. Square roots, any even root has a restriction. Whatever's under the radical cannot be negative. This 2 doesn't affect the domain at all. Because all I'm going to do is, once I've evaluated the root, I'm going to add 2 to it. And I can add 2 to anything. So the thing that has some restrictions are, can I actually evaluate that root? So I'm just going to look at that and say 5 plus x can't be negative. And that means it has to be bigger than or equal to 0. If I subtract over the 5, that means x is bigger than or equal to negative 5. If I were to draw that graph, again, not absolutely necessary, but I kind of like to have that picture. There's negative 5, and this time I've got everything that's bigger than or equal to that. So I can see that my domain has negative 5 as a left endpoint, and this one has no right endpoint, so it goes off to infinity. All right, to find the y-intercept, again, if we're looking at, let's see, yes, x and y, if we're looking on the y-axis, that means our x value is going to be 0. So what's going to go here will be k of 0. So I'm going to just take my formula for k, where there's an x there, I'm going to plug in a 0. So I replace that x with parentheses as a placeholder for my input, and now I'm just plugging in 0. So I'm getting 2 plus root 2. Now root 2 doesn't simplify nicely, so these guys are not like terms, which means I can't combine them. That's 2 plus root 2. If they're not like terms, I have to keep them written as separate terms like that. Now, if this had been a 4 under here, I could simplify the root and say root 4 is 2, and then I could add it to the other 2. But if you see something like this, a lot of times students are like, oh, I should be able to simplify it more. Not always. If they're not like terms, you can't combine them. So there's our y-intercept. And now let's get our x-intercept. So for the x-intercept, we'd be on the x-axis, which means that our y value will be 0. So I'm going to see, what do I need to plug in to make y 0? So 2 plus root 5 plus x would have to equal 0. I'm going to subtract the 2 over, so I get root 5 plus x equals negative 2. Now I want to do that before I square both sides, because if I were to square this side as it is, it wouldn't just lift the radical. I want to remember that when I'm squaring something, I'm squaring the whole thing. So if I had 2 plus the square root of 5 plus x squared, that would mean 2 plus root 5 plus x times another copy of 2 plus root 5 plus x, and I need to FOIL that out. So my first terms would be nice, but my outsides and my insides would still have roots there. So before I square, I want to isolate the root. Now if I do that, I say, oh, a square root equals a negative. That has no solution. So there is no x-intercept. Now if I didn't notice that and I squared both sides, I'd get a number that I might think was a potential solution. But remember, if you're solving an equation by taking both sides to an even power, it's necessary to check. And if you did square both sides and get an answer and check, it's not going to work. So there is no x-intercept for this problem. All right, let's take a look at the second part of 4. So that was p of t equals the 5th root of t plus 2. Now 5 is an odd number, so this is an odd root. So the domain is everything from negative infinity to infinity. Okay, if I want to find the y-intercept, if we're on the y-axis, t is 0. So I'm going to have a point with the t value of 0, and then to figure out the y value, I'm just going to plug in 0 for t. So p of 0 would be the 5th root of 0 plus 2. That's just going to be the 5th root of 2. And that doesn't simplify nicely, so we'll just leave that as the 5th root of 2. All right, so then if I want the t-intercept, that's going to be where we're on the t-axis, which means our y value is 0. So it's going to be a point whose y value is 0. And I'll find that by simply taking this formula, 5th root of t plus 2, and setting it equal to 0. To undo that 5th root, I'll take both sides to the 5th power, so I'll get t plus 2 equals 0 to the 5th. Basically just raised both sides to the 5th power. So t plus 2 is 0, so t is negative 2. And I don't need to check. So odd roots are actually nicer to work with because there aren't restrictions on the domain, and when I solve by taking things to an odd power, I don't need to check those answers.